Hello, everyone. My name is Kevin Tarr. I'm an iOS engineer, and today is day 30, officially day 30 of algorithms in Swift. So I say hello to you from the year 2020, COVID 2020. You can tell that I'm speaking to you from the future because of my hair length, as opposed to day 29, which was um, last year. Um, but I thought today would be a great day to continue the series and give you more algorithms going forward. So today we're actually going to do a problem. It's a problem I actually saw off LeetCode. It's a problem dealing with duplicates. Now we did a duplicate problem before, but the duplicate problem that we did was actually a bit more simpler than this problem that we're going to do because of the parameters and limitations and the strict requirements of this problem. So I think you're in for a very, very interesting problem that we're going to solve together, and we're going to master and conquer, and you're going to learn something new. Okay, everyone. So here's our problem. Problem states: given a sorted array named nums, remove the duplicates in place such that each element appears only once and return a new length. Do not allocate extra space for another array. You must do this by modifying the input array in place with O1 extra memory. And here's some test cases. Given an array of 1, 1, 2, the length should return 2 because you're moving the 1, extra 1. Given an array of duplicates 0, 1, 2, 3, 4, it should return 5 with the elements 0, 1, 2, 3, and 4. But this is what I was talking about earlier um, in terms of complexity, added complexity, because we can't use an extra array or an extra collection type to be able to remove duplicates and filter them. We have to modify it in place, which is a bit more complex. Because normally in previous videos, we would just take elements from our current array, for loop over it, and any element, and then check to see if this array, create a copy array, check to see if the copy array um, already had contained the element that we're going over. If it didn't contain it, we just added it because that means that it was a unique element. Um, and if it did contain it, if this array did contain it, then we didn't add it because that means we'd be adding a duplicate. And we just return that array, and that solves our problem, or return a count in this case, and that solves our problem. But today we have to approach it a bit differently. And my approach to this is doing it instead of thinking about it like two boxes, filtering out one box for using one box, one empty box to filter out another box, two different arrays. We can think of it as an assembly line where we're just picking duplicates. And since this is a sorted array, the duplicates, all duplicates are going to be right next to each other. They're going to be adjacent or contiguous, I guess. So you could find each element. You could every time you find a duplicate, you remove it from the array, and then all the elements that are behind that array, you just move the indexes, subtract the indexes by one, because the elements every time you move an element out of an array, the array count gets shorter, and as an effect of the array count getting shorter, all the elements behind it, their indexes, so it can get subtracted by one to compensate for that. So that's the only critical part about this, but this solution is pretty straightforward to solve. So let's begin. So we call this func remove duplicates. Call this nums. Call this an out because we're going to be modifying the array in place, and it's not going to be a let constant. We're going to first guard the array. So first we're going to take care of our edge cases. Guard array, nums count is greater than 1, else return nums count. That's just checking to see if the array is empty. Then we create var current number equals 0, and then var index subtractor, and that's a good name. That's the number we're going to use to compensate for every time we remove an element out of the array, and the array getting the length getting shorter. Then we're going to do for index number and nums dot enumerated if index equals 0. Then we're going to assign current number to number, just to start off our duplicate comparisons. Else, if current number is equal to number, that means we found a duplicate, then we just remove it, add the index minus index subtractor to compensate for the array indexes collapsing. And then we just add 1 to the index subtractor. Boom. Then we do else. If it's not equal, meaning we don't have a duplicate, we have a new unique number, then we just add that, we just assign that unique number to current number. And then we return the nums.count. Okay? So let's do this. I don't know why the error is there, but we're gonna see if we can get rid of it. So var a equals, let's do a test case here. So this is a test case right here. Come on, Xcode. Yep, 5. Okay. And for visualization purposes, let's just actually return the array so you can see the array being reduced to 0, 1, 2, 3, 4, 5. Or 0, 1, 2, 3, 4, excuse me. Sorry, let me take care of that error. Sorry. All right. Yep, 0, 1, 2, 3, 4. See right here? 0, 1, 2, 3, 4. And we add 5, 5, and 6, 6, and 7, 7. We should get an array of 8 elements going from 0 to 7. Yep. And if we do the count, we also will see the same thing. We should get 8 back. Oh, sorry. Gotta change the return type, excuse me. Eight. Yep. Okay. And for clarity purposes, we can actually just run this in LeetCode to see how it looks. So let's do that right now. So let's remove this. Sorry, extra function call there. Let's submit. Boom, 21 megabytes, less than 76%. So that's, I think, actually pretty good. We did better than 76% Swift Online submissions. All right, so guys, let me know what you guys think of the problem in the comments below. Hit like and subscribe now since we're on YouTube. I look forward to seeing you guys tomorrow. Peace.